Okay, example 3 on section 8.3, it says to test the effect of an herbal treatment on improvement of memory, you randomly select a sample of 10 people to receive the treatment. Before they start the herbal treatment, each person is given a memory test. So here's their memory score before they were given the herbal treatment. They are given a similar memory test after the treatment. Okay, here's the same 10 people after they took some herbal treatment for several weeks. And it says, test to see if they had significant gains in memory, summarized at the most significant alpha level. Assume the differences are normally distributed. We have to assume they're normally distributed because we have a small sample size. And also, we're checking to see if they had gains in memory. So if we're checking to see if we had gains in memory, we expect this number here to be higher than this score here. So the after is higher than the before. So when you go before minus after, 70 minus 75, you get a negative number. Even if we didn't get a negative here, we're expecting we're testing to see if this is significantly higher than this, because we're seeing if their memory score is significantly higher after they took the treatment than before. So even for some people that maybe went the opposite way, we're checking to see if they did go this way, that this is higher than what this is. So when we subtract a score minus a higher score, you get a negative number. So we're going to be doing a left-tail test. So let's go ahead and get this data. It's on the data sheet right here. And we'll highlight that and copy it and take it to our paired t-test. And here we go, the paired t-test, and we need to get that data in here. So right mouse click and paste special as values. Get that in there. Now let's get rid of any extra data we have, which is these numbers here. So get rid of any extra data you have. Should be 10 people in there, and there are. There's the average improvement in memory. You see that most of these are negative, meaning that they improve their memory. Here's a person that after they went on the treatment, their memory score actually went down 2 points. 90 minus 88 is positive 2, meaning they went down 2 points. This guy, 70 minus 75, he actually went up 5 points on his score, but the average increase was 11. Like this person right here, after the herbal treatment, they went up 27 points. The average increase was 11.5 with a standard deviation 11.8, and here's my sample size. Copy those over, and we're going to be doing a left-tail test on this. Okay, we're checking to see if significant improvement, making the after score lower, before minus after score higher, and before minus after would be a negative number. Checking this, the p-value is very small right there. We'd be able to reject that clear down to the 0.01 alpha level. So we'd say at the 0.01 alpha level, I was able to show that their scores, their memory scores after the herbal treatment were significantly greater than the scores before the herbal treatment. Not just for them, this is making an inference up to the entire population, and that's why that's so important, is because this is making an inference up to millions of people from just 10 people. That's it. So it's quite a powerful thing to do that. I would say definitely you should have sampled more than 10 people if at all possible. But if you only have 10 people, that's all you can sample. Let's go ahead and do one of the homework problems from this section. Okay, on this problem it says the teacher wanted to know if there were significant gains in ability to understand statistics from the beginning of a course to the end of a course. 30 students took the pre-test and the post-test. Use the data below to see if the students made significant gains in their ability to understand statistics and summarize at the most significant alpha level. Also write the null and alternate hypothesis. The average gain in ability, the standard deviation in the gain in ability, the p-value, and a 95% confidence interval for the gain in ability, and summarize. So let's see. We're supposed to summarize this, I think, at the most significant alpha level. Now the data is right here below problem number 2 here, and that's the data that you're supposed to use on this, and it's actually on your data sheet. So let's go to the last sheet and data, and this is for exercise 1, and actually exercise 1 and 2 uses this data. So let's go ahead and get this. So let me copy this data and go to the paired t-test, and here is the paired t-test, and we want to put that data right here. So we'll paste special as values, get that in there, and we got our data in there, and we can see that here's how much the score increased by 37 on average. 37.5 points is how much the score went up by. Like this person's score went up by 45, 45 points here, 45, you know, a lot of improvement here. Let's copy these values over. Okay, we're doing a left tail test here because we're checking for significant gains in ability to do statistics. And if you look at this, we can see that the p-value is basically 0. It's very, very, very close to 0. So you can reject this at a very small alpha level. And we'll go clear down to the smallest one that we use, which is 0.0001. So we can say at the 0.0001, students' ability to understand statistics significantly improved from the beginning to the end of the course. And you could even change some numbers in here and see how much it significantly improved by, but it definitely significantly improved. Now, you could have a course like that, and that's really about all there is to that problem. It asks for a lot of little things like what's the X bar D, the average gain, the standard deviation, the sample size. It probably asks what the p-value was, which is very close to 0. If you want to know what that is, we could probably format this cell, let's see, and write it in scientific notation. It's such a small p-value. Let me see, number, and we want it in scientific. If you want to actually see this number, it's 1.4352 times 10 to the negative 18th, which means it's 0.17 zeros and a 1, 4. Okay, 0.00017 zeros, 1, 4. So it's very close to 0, that p-value. So 0 is probably good enough, but it's less than this alpha level anyway. In it also, if it asked anything else like the test statistic or critical value, it's right there. Now, if we needed to do a confidence interval for this, we would take this data and make sure it's over here. And then at that point, you put in your confidence level here. You don't have to do the 1 minus the thing like we did before. We don't have to say, oh, well, if this is 0.05, this is automatically 0.95. You can get any confidence interval you want right here. So this particular problem, I forget if it said what at 95% confidence interval. So here's my 95% confidence interval. In other words, I'm 95% sure that the average gain in ability is somewhere between 33.7 points to 41.25 points. So that would be the summary for that confidence interval right there. And notice that there was significant gains, even though if you wanted to see how many people pass this course, this is just a theoretical course, but notice nobody had a higher score than 55 on this. So you can have significant gains, yet nobody passed the course. So that's what question 2 was about. So we'll stop it right there.